Alright, so vertex form is nice because it just shows shifts and it shows the vertex. So we like vertex form. So if there's a number in front of the parentheses, we call it A. If it's negative, the parabola goes down instead of up. If it's greater than 1, then it's a skinny graph. Stretch means skinny, stretch up. If it's less than 1, then it's a shrink, which means wider. This here, this letter, it's a fancy Q. Fancy Q. Well, these are 3 forms of quadratics. Quadratic equations, parabolas can be written in any one of these ways. The one we're working on right now, vertex form. These are all parabolas. This is when we were factoring. That's factored form. Vertex form, standard form. Alright, the H value. Notice here that there's parentheses and it's squared. If there's a number inside there, that's the axis of symmetry. So you don't have to do negative b over 2a. You don't need the formula. In this form, we have to do negative b over 2a, a whole formula. In this form, it's the h value. Now, the minus sign is there. So if this says minus 5, 5 is the h value. It also shows the shift left or right. Now, I haven't mentioned anything about K shows the shift up and down. Okay, K so many things. It's the y value of the vertex. Well, I used to not write all this stuff down. I felt like it was too much. But some people want to know. Like some people want to know that K is the y value of the vertex. So I better just put it out there. K is the y value of the vertex, and it shows a shift up or down. So that's everything I have to say about vertex form. When you're ready, get out the handout from yesterday. I want you to think on your journey about what you were doing last Tuesday. I'm talking to you. Right here. I want you to think about last Tuesday. If you got caught out for anything. How did you do? Yeah, I think you can. You want to try it? These are bugs. Oh, I wonder if these are bugs or vocabulary. Then do it. Right here at the top it says HK is the vertex. There it is. HK and H is the axis of symmetry. Yesterday I asked, please do this one for homework. I want to remind you that this And we did this once before on the graph paper that you folded hamburger. Negative 2 squared is a positive 4. Negative 1 squared is a positive 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So it starts at 0, 0, has an ordered pair at 1, 1, and has an ordered pair at 2, 4. Now I keep saying one more ordered pair. Does anybody know what the next point would be? 6. If x is 3, what would y be? 9. 9, because 3 times 3. And if x was 4, what would y be? 16. 16. If x was 5, what would y be? 25. That's what we're doing here. We're squaring x. Alright, here's our parent function. Now, in this first example, we're going to use transformations to describe how each one of these equations would be different. This 4 is in the h spot. We call it h. A number in parentheses we call h. That means the axis of symmetry is 4. So this one has an axis of symmetry of 0. If I put a minus 4 in here, the axis of symmetry shifts right 4. So the answer is shift right 4. You don't have to make a graph, but you're trying to just figure out, looking at the equation, can you visualize the graph? I'm picturing the parent function right 4. That's all that 4 will do.
So basically, since you took that number, all you have to do is square to get the answer for the graph.
Yeah, you could put it. Yeah.
So since there's no like the value, so this like the 4 and negative 4 and the 0 would be the
Now watch. I'll show you.
Fill in the table with the other numbers.
You could, but you don't need to. You could just count this to the right 4. It's this exact you shifted right 4. So that's the quick way. Now I want to show you, because you asked about B, what B is, really quick. If I wanted to know what B is, I would move it from here to here, and then I would do the window, and I would FOIL it, and I would get x squared minus 4x plus 16. This is x squared minus 8x plus 16. Okay, these are the same thing. So this is got a B value. So I could graph it this way using the old method, negative b over 2a, or I can graph it this way. I know it's going to be right 4. See the connection?
All this math literally just goes in circles.
It's all right here. This is called math thinking and reasoning. Demonstrate understanding by representing problems in multiple ways is a huge game of algebra 1. Seeing any equation represented in different ways. As you do it, you're supposed to understand each form better. Like this was good for plugging in zeros and getting intercepts. This was good for slope. This was useful when we had to find parallel and perpendicular lines. This is good for real world math. There's a quadratic formula. This is good for transformations, and this is good for x-intercepts.
Can you give me instance and when you would have to use these in a real life situation?
Yeah, anything that goes up and comes down in gravity is a quadratic. So everything projected. Did I show you guys the videos last week?
So like shooting a basketball or like
Yeah.
throwing a football or something.
Mm-hmm.
God, they be doing this calculation for football fields.
Yeah.
Oh, wow.
I'll show you videos tomorrow. I have videos.
You got energy, dummy.
Okay.
That's not what I'm looking at.
Yeah,
I know I'm
this
being
is number
annoying.
one. I'm going down for number two. I'm not going right, left. I'm going down. Okay. Now look at this this six. It looks different than the four. There's no parentheses. That means this is a K value, not an H value. H's are in parentheses. K's are at the end. So this is a shift of six. That's the answer. It's just a shift of six.
This
Yeah.
X, which one excluded being -4?
In the vertex. No, actually be positive. In the vertex.
Why would it be -1? Oh, because it's squared.
Kind of, yeah. Alright, and in this one, this is called A, right? A is 1/3. So, this is less than 1 because 1/3 is less than 1. This is a shrink, which is a wide parabola. The 1/3 makes it look really wide. You could just say shrink of 1/3 is the answer. Alright, this is just like the parent function, but there's a negative sign in front. So the A is a -1. So this will open down instead of up. That's called a reflection. This is exactly the parent function, but flipped so the arrows go down. And number 5 is where the real works at. It has an A, an H, and a K. So number 5 is putting the whole thing together. So here I would say A is -1. H is the most difficult. H is -3 because it's opposite of how it looks. And this means that K is 5. So that's what we call those, A, H, and K.
Why is it -3?
For the same reason, that's a +4. Because it was like this. The minus sign is there. If I put a -3 in, it appears to us as a positive. But it's because I put a -3 right next to a minus sign. There's, yeah, that's a minus sign in the form.
Why did you show us this version last if it was the easiest? Is it because we still have to know the other ones?
Yeah, you gotta know both. It's really difficult to transition to start in this and rewrite this way. You'll do that in algebra too. It's called completing the skirt. It's in your algebra 1 book, but going from this way to this way is easier because you use the window method.
Yeah.
So anyway, we start with this because it's more standard. It's actually with linear. We started with this, but we plugged in zeros and found intercepts, even though this way's better. You start in standard. So, what's happening in 5? There's a reflection. because A is -1, it's going to be shifted left 3 because H is -3, and it's also shifted up 5 because K is 5. The center is at -3, 5. So if I had to graph number 5, I wouldn't even make a table. I would just put a dot at -3, 5, and then I would draw the parabola going down. But I got the parent function memorized, so you just gotta practice. This is all yours. That number 5 has all 3 transformations.
Why is it shifted left? Like wouldn't it be opposite whenever you right? It's negative?
Well, when I look at it, the opposite means this number is different than how it looks. It looks like a +3. Normally, plus means move right. We're actually going to move left. So, to me, it sounds like you're doing opposite twice. Okay? Since I said it was -3, go left. We'll practice. Okay, so this is A equals 2, which means it's a stretch. It's tall and skinny. And this is K is -4, so it's shifted down 4. We're ready for the day. What's that? Yes. With the K, you see negative, it means down. That's what we were saying. Number in front of X squared. If it's not a fraction or a decimal, it's skinny. But fractions are wide, like numbers less than 1. See, this one was a 1/3, it's wide. This is a 2, it's skinny. Like twice as tall. Alright, flip it over. We're gonna actually draw these now. So right away, I want you to go ahead and draw the parent function on all 3. Draw the one in the middle on all 3. Before we even do the problem, draw y equals x squared on all 3. So whatever we did in the front, the parent function, go ahead and put it on all 3. I'll put the table here for you if it helps, but the more quickly you memorize this, the better. 0, 0, -1, 1, -2, 4. So we're going to start with this one on all 3 of them.
Nice crispy treat. Oh. Oh yeah, snap, crackle, and pop in the
And then, if you got that down, figure out when you're ready, try the vertex. I hate that first step. I'm going to cross that out.
Wow.
You know how to do this.
Yes, do we have to write the first what is it called? Yeah. But do we have to like draw it instead of drawing like a translation or whatever?
Sometimes you're on to it, sometimes you're not. They got big ideas, man. I think you have to do better. Right. Like this one's gonna be right. But so Allison, to answer your question, right? H here is actually 6. And K is -4. Like the negative sign belongs to the equation, not the 6, which is any of those. So this is going right 6 units. The vertex is 6, -4. So yep, it's gonna be right 6 down 4. So since I have the one in the middle, I can just count right 6 down 4. And I can do that with all of the points. There's a point here, here, and here. So I don't need to make a table because I know there's no stretch or shrink. It's over 1, up 1, over 2, up 4, over 3, up 9. Like, that's how the points go.
Surprising. Don't lie. Don't lie.
So I started with this one, right?
Don't she be hitting me?
Yeah. Now you can make a table to get the other points. And sometimes I need to. But I want to show you the shortcut is to move each one of these right 6, down 4. Like, do you know where I got these points from? On the red? Okay, those are from the front. This is from the front page where I pulled up for this one. That's how the so if you can draw that one on the back, you can just move that one around. It's quicker. Oh,
I have.
Oh, wow.
and you guys ship triangles and stuff in pre-algebra, I'm pretty sure. You move shapes left, right, up, and down.
Yeah.
If not, then at some point in your lower level math, you're moving a shape left, right, and up and down. We're just moving a function now, a whole equation. I haven't mentioned this at a math sermon.
Why
It's the y value of the vertex, so the minimum point is y equals -4.
Oh, yeah. Yeah. Oh, that's right.
And so domain is our row number, and the range is y is greater than -4. So Megan, as soon as there's a parentheses with a 2, as soon as there's a parentheses and squared, we don't have a B and a C anymore. They're called H and K. Okay? So I can't make an ABC with vertex form. They're H and K. H and K are the most special points. They're the middle points. H and K are way better than B and C.
Which one you want? I said, which one you got?